In this lecture, we're going to talk about something called a myogram. And a myogram is really important for assessing muscle function and diagnosing issues. If somebody has an issue with their muscles, whether it's a mechanical issue or a chemical issue, whatever it is, you can learn a lot from something called a myogram. Remember, myo means muscle, and gram is Greek for what is written. So what we're doing here is we're recording what's happening in a muscle. So let's get started. So basically, again, it's just a pattern or graph of a muscle contraction. And this is the thing that's a little bit confusing. You've all felt a twitch of a muscle before, right? Your eye like twitches, or if you feel like a weird twitching sensation, that is a muscle twitch. That is not normal muscle function. That's the analogy I use for that is the equivalent of just turning your light switch on and off real quick. So it'd be like if you went into your room and you just turn your light switch on, turned it off again real fast. That serves no purpose, right? It's not lighting anything up. So a muscle twitch is not normal muscle function. What it is one single muscle contraction. And that is not you. Like, for example, if I pick up my coffee cup right now, that would be like if I picked it up, put it down, picked it up, like this. That is completely non-functional, right? So when you use your muscles, you sustain a contraction, but it's made up of many muscle twitches. So a single contraction is a muscle twitch. Again, not normal function for a muscle. If your muscle twitches, that means that there's some message wrong that's going wrong. Your muscle's just being fired off over and over again without sustaining that contraction. But we'll get more into that later. Let's talk about what's actually happening during a muscle contraction when we're talking about a myogram. And if you take a look here, this is a myogram right here. And as you can see, it's broken into three distinct phases or parts. There's the lag phase, the contraction phase, and the relaxation phase. So I'm going to just talk about those, and then we're going to talk about the different things that can happen when you're actually using your muscles. So the first part of a muscle contraction or a myogram here is what's called the lag phase or the latent phase. And what that is that there's a little bit of a delay between when the muscle gets stimulated and when it actually contracts. And there's a reason for that. There's actually stuff going on inside the muscle, right? So for example, when a muscle is stimulated by a neuron, the acetylcholine crosses the synapse. It causes the sodium channels to open, sodium floods in, and then that impulse travels down the sarcolemma, down the T-tubules. It releases calcium from the sarcoplasmic reticulum, and then that calcium makes its way over to the troponin, moves the tropomyosin out of the way, and then finally those myosin heads attach to the actin and pull it inwards. Well, all those things I just said take time. Now, they take milliseconds, but they take time. So the time it takes for a muscle to contract, it's basically what's going on there is that's how long it takes for the impulse to get down the T-tubule, open up the sarcoplasmic reticulum, release the calcium, and then get the calcium over to the troponin. So that is why that lag phase exists. It's the time from when you flip the light switch on for that electrical impulse to travel through the light. It may not seem like there's any, time there that occurs. It may seem when you flip that light switch on, the light comes on, but there is a slight delay there that you can't pick up with your eye usually, but it happens. The same thing is true here. That's the lag phase. So that's what's happening during this little time period before the muscle contracts. Then we have our contraction phase, and that's when the muscle is actually contracting. The actin and myosin have come into contact, form the cross bridge, and the muscle gets pulled inwards. That's the contraction phase. And then finally, the relaxation phase is when the calcium gets pulled back into the sarcoplasmic reticulum, the troponin gets put back into place with the tropomyosin, those myosin heads detach from the actin, and you have a muscle relax. So that's the normal phase of a muscle. So that's a single muscle twitch. What I'm going to do now is I'm going to go through different possibilities of what can happen with a muscle twitch. Because again, that's not normal function. You don't just twitch your muscles, you use your muscles. So let's talk about that. These are called patterns of contraction, and there's actually 4 patterns of contraction. The first one I just went over, and that is called a muscle twitch. So a muscle twitch is very simply a single muscle contraction, and I'm just going to go over that again one more time. So again, there are 3 phases to a muscle contraction. There's the latent or lag phase, which is that initial time period before the muscle actually contracts. There is the contraction period where it actually is contracting. And then there's the relaxation phase where it goes back to being relaxed, right? So that's going to be a single muscle twitch. Again, that is not a normal situation. That is not normal muscle function. So let's get into actual muscle function. So if you're getting into exercise physiology, physical therapy, occupational therapy, sports training, this is all right up your alley. This is the kind of stuff that you'll be learning about and dealing with. So the next type of pattern is called a staircase effect, and this is a more realistic version of how a muscle actually functions. So what is the staircase effect? The staircase effect is when you have multiple contractions, one after the next, which eventually will increase in intensity up to a certain point. What does that mean? What's going on here? Well, basically, let's say I want to hold my phone, okay? Or more realistically, I want to throw a ball, or I want to, do a push-up. Whatever the scenario is, every time a muscle contracts, it's going to get a little bit of a stronger contraction, one after the next, until you hit a certain point where it levels off, where it plateaus. So if you take a look here, this is a staircase effect. There's a slight increase, a slight increase, slight increase, and eventually you end up with a scenario where it just levels out. So let's talk about why. Why would the muscle contraction get stronger with each, subsequent contraction? Here's why. That's why warming up exists. If you've ever played any sport, before you don't just run out into the field cold. You warm up first. That is getting your muscles ready to go. There is a reason why you do that, right? What it does is when your muscles are warming up, you're getting them ready to contract. So, for example, let's say I have a muscle contraction, and then I relax that muscle, and then I immediately have another muscle contraction. My brain sends another impulse to that same muscle to have it contract again so I could, do some action. Well, a lot of that calcium is still in place. Remember, this muscle is a large, unit of protein fibers, and it doesn't all happen at once. I use a light switch as an analogy, but it's not really like a light switch. Not all the calcium gets removed at the same moment, right? So some of that muscle may still be slightly contracted even when the muscle relaxes. So when that second stimulus comes, some of that calcium's already in place. Also, not all that calcium's gotten back to the sarcoplasmic reticulum. So some of that calcium's probably still floating out there in the cell, so it's going to be able to get back to the muscle fiber much quicker. So with the staircase effect, you get a scenario, and again, I'll go back to that diagram just because I think it's helpful, at least for me, to draw this out. So what you have is a scenario where you have the first contraction, you have your stimulus, your contraction, and your relaxation, and then you immediately have another one, which has a slightly stronger contraction, and then you immediately have another one. So why do they increase as they go up? Well, the reason why they increase as they go up is because that muscle is already prepared to contract. It already has calcium in the general area, and it's ready to go. Now, why does it plateau? Well, at a certain point, your muscle's only as strong as that muscle, right? I can only lift how much I can lift. If I want to increase that level, I need to increase my muscle size. So the reason why it plateaus is because at a certain point, that muscle is going to just hit its limit as to how much strength it has. Mr. Ranieri is much stronger than I am. No matter what I do, I can warm up all day long. I'll never be able to lift as much weight as he does unless I build more muscle. So that is the staircase effect. It's the idea that a muscle will contract multiple times, and each time it contracts, that it will become a stronger contraction up to a certain point because of the fact that there's a limit to how much a muscle can hold. Okay, let's go through the last two. The next one is called summation. And summation occurs when there's a contraction that occurs before the muscle can completely relax. There's a second contraction that occurs that builds off the first contraction. And that is something that you've probably experienced before. One of the hardest things about doing pull-ups is when you do a pull-up, you're supposed to pull yourself up, and you're supposed to let yourself go all the way back down again to completely relaxed, and then pull yourself back up again. Now, what we all probably do, myself included, is we pull ourselves up, we get to about here, and we pull ourselves back up again. And the reason why is because when we get to about here, our muscles aren't fully relaxed yet. So when we pull up again, what we're doing is we're essentially using the force of that first contraction to help propel us into the second contraction. So if you want to get a really good workout, what you should do is let yourself completely relax and then pull yourself up again, because you're not building off of that initial contraction. So that's what you're seeing here. You have your first stimulus occur, and then before that muscle can relax all the way, it's going to contract again, and it's going to build off of that initial contraction. So if I go back to my diagrams here, that would look something like this. Let me pull down here. So it would look something like this, where we have our initial contraction, and then it starts to relax, and before it can completely relax, the brain sends a message and it contracts again. And what you end up with is a scenario where the initial contraction, right, propels that secondary contraction, and you get a much stronger contraction the second time, and that is called summation. And an example of that, like I said, would be if you were doing a pull-up, and then that second pull-up, you're not letting yourself relax entirely. And that's just a way to kind of cheat a little bit. So you might see people in the gym doing that. They're doing these really short, quick movements, and yeah, are they able to push the weight up? Yes, but they're benefiting off of the initial contraction. So, you might not want to tell them that. They might get mad, but you'll know it, and you can think, you can feel superior, right? And then finally, we have tetany, and this is what we consider normal muscle contraction. And tetany is a scenario where you have many muscle contractions that get closer and closer together until eventually they become a sustained contraction. And that will stay contracted until you run out of energy. That is what we do almost all the time. For example, if I'm holding my phone right now, I'm not picking up and putting it down. I'm just holding it. And the reason why I'm holding it is because my brain is sending messages over and over and over again to the same muscles, and that muscle is going to eventually hit what we call tetany. And tetany is when it sustains a contraction. So it's a sustained muscle contraction. And that would be considered what we think of when we think of like normal muscle function. You're not normally sitting there throwing a ball, right? You do that sometimes. You pick something up, you put it down. But if you're holding something, that is an example of tetany. So it's when the twitches fuse together into one sustained contraction. So if you take a look here, you can see tetany. There's lots of small contractions that are getting together, and eventually that stimulus is going to cause one sustained contraction, and that's going to continue, and it's going to continue on. So if I go back to my diagrams there, what that would look like with tetany would be many. You're going to get your staircase effect. It's going to increase each time. But because these are so close together, eventually they're going to become one sustained contraction that's going to continue until one of several things happens, right? The person relaxes that muscle, the message stops going to the muscle, or they run out of ATP. And if they run out of ATP, that's going to either cause a cramp, which happens, or muscle failure. So again, just as a quick review of what I just talked about, there are 4 patterns of muscle contraction. The first one is a twitch, and that is not a realistic scenario. That would be a muscle just going like that. And you felt that before. You felt muscle twitches in your eye. You felt them in your small muscles of your hand, right? We'll talk more about that later. The staircase effect is the idea that when you have multiple contractions, one after the next, and they're spaced out enough that they don't form a tetany scenario, each contraction is going to get stronger than the one before it. Summation is when you have one muscle contraction building off of an initial contraction, which leads to a much stronger contraction. And then finally, with tetany, you have multiple, you have a muscle that is constantly being stimulated, and eventually it becomes one sustained contraction. And again, that is the more common way we use our muscles. Sitting upright, my muscles in my back are in tetany. They're holding me upright. If you're holding your phone, you're holding a coffee, holding a pen, all of those things would be an example of tetany. Thank you very much.